guess everyone would have heard about the generative adversarial networks, which actually learns to create its own generative own images based on some samples. For example, if you have a data set of cars, it can learn to create new cars, and the way it works is really interesting. That there are two neural networks where one is generator and another is discriminator. Generator is what produces the new images, and the discriminator tries to learn the difference between those two, and both of them try to overpower each other, and the generator becomes very powerful, that the output is literally not perceptible. So, for example, I think a lot of people would have seen this person does not exist. This is became very famous, and people would have seen. But apart from that, there are also a lot of other uh, new generative adversarial models, like this cat doesn't exist, and anime characters, and even there is a Stack Overflow question generator, or even something like a startup site generator. Yes, that's yeah, it will be inside one of these. So if you see if you read this question, you will not find out that it is created by a machine learning model. You would think that it is created by a human, and even it can generate like answers, proper answers for it, etc. So it is something very interesting. We have this super resolution, which can actually clarify images using generative adversarial networks. So this is something that is also currently used in NVIDIA's DLSS technology, where gamers can use can view at a higher resolution, but the produced image will be lower resolution like this. So that is an easier way to upscale an image. And style transfer is also one of the other things with generative adversarial networks, where you have a photograph, and you apply a style like this painting, and it will generate your image with the same style. So you can see these examples how accurate they are. And another important and exciting application is this extrapolation, where you can just generate you just have to denote what has to be there in the image, whereas the neural network can paint or create photorealistic images for yourself. So there is an NVIDIA AI playground where you can try all these. Just go here. So you can you have to check this, agree this for this box, and then you can paint your own landscapes, photorealistic landscapes, rather than. So for example, if I want a rock here. Yeah, so it can generate photorealistic images just based on these segmentation maps. And NVIDIA's even launched a new desktop application called Canvas, which currently it is in beta, but soon it will be out. So, and similarly, image in painting is where you can clear uh, marks like these, or even people who are photobombing your selfies, etc. So you can remove it and move them with AI, so that it does not look weird. And a further extension of this is you can generate images using just description. So if you just say, for example, here generate an image of Elon Musk with blonde hair, it generates that for you. It creates kind of like its own rendition of that and provides it to you. And another thing is like self-supervised learning. So whenever you're building a image recognition model, we have to collect a large number of labeled data sets. So without that, it does not cannot train itself. But self-supervised learning is where the model can learn by itself, and you provide only very few labels and not a whole lot of them, and the model can learn by itself. So the important thing is how it works is It comes up in the next slide, but for example, what Facebook did is like just collected 1 billion random unlabeled and uncurated images from Instagram and trained it over the self-supervised models, and with just 10 percentage of labeled data set from ImageNet, it was able to achieve 78% accuracy. So this is really a huge feat, given that it has used only 10 percentage of labeled data set. And how it works internally is it uses the unlabeled data set. For example, here there are two images. One is dog and chair. So it creates multiple versions of the same image, which we call it as augmentation. So for the same image, it can create multiple ones, and it will try to learn that these two are not really different images, but they are just same images. But comparison between dog and this chair is made as like they are different objects. So it just learns to understand that what objects are different and what objects are similar, but it does not learn how to what are the labels actually. But when you provide just a few labels, it will be able to differentiate between each other, and just with fewer samples, it will be able to learn a task. Currently, a recent trend is transformers in computer vision, and not just in computer vision. Transformers are being used everywhere, and that should be attributed to the recent successes of transformers in NLP through the models like BERT, T5, and GPT-3. So you might have heard of GPT-3, but if you haven't, I would recommend looking at it, because it can produce amazing texts. So currently, what is being researched is transformers have lower prediction overhead rather than convolution neural networks. So that is the reason transformers are being used, and it is being followed tried from Google and Facebook, as well as Microsoft. So you can see here, this is a graph that shows how fast the model can perform with transformers. So you can see that nearly 100 images per second the model can process with 85% of accuracy if you are using transformers. If you are talking about the convolution neural networks with same accuracy, it won't be able to reach this level, so it would be much less. And apart from that, there is also, if you're talking about any software or anything, there will be definitely attacks, or if you change input in different way, the software can work in unexpected ways. So a few attacks were found for neural networks. For example, if you have an image recognition model which predicts this as panda, which is correct, and just add very small perturbations and produce this final result, we as humans, we cannot differentiate between these two images. They are just exactly the same. But neural networks, when this one is given as input, it produces output as given with 99.3 percentage confidence, which can be crazy. And you may think of what could be the security implications of this. For example, face recognition models use computer vision models, whereas but you can't really input a generated image like this. You can't create a noise and then pass it to your software, right? It is capturing it directly. But researchers have demonstrated using 2D printed glasses. You don't even need 3D printers for it, and with small perturbations in the glasses itself, they are able to full face recognition software that this person is this, and this person is this, like that. So when face recognition software saw these people with these kind of perturbations in the glasses, it was recognized as a different colleague or even some celebrity, like that. So these are some things that have to be overcome on any neural networks. Neural network models have to be robust against these kind of adversarial attacks. So there are few ways to resolve these. One is to have those adversarial examples in the training data itself, so that uh, the model can learn to differentiate between it will not be able to differentiate between the adversarial and normal example. And another simple way to resolve this solution problem is denoiser. So whenever you get an image, you know that there could be some noise which is going to be the attack. So you just use denoiser, which there are like a lot of denoisers, and then run the prediction so that it can be effective. And also there are additional methods like augmentation of images using adversary attacks, so that the model itself can learn, and it is shown to improve the accuracy along with robustness, not just robust with adversarial examples, but also it can improve the accuracy than normal training of these image recognition models. And these are like latest trends that we are looking at for computer vision, where new techniques are being